Hi, this is Steve Tennell, and this is another series on mechanical ventilation from Lung Treater. Thank you for joining this podcast. Today, with all the talk of COVID, I have my face cover, and all the talk of ventilators, I thought it would be important for us to look at ICU quality ventilators. Not all ventilators are created equal. This ventilator that I'm going to review here is a product of Event Medical, Lake Forest, California. And I want to thank Kirkanoe for allowing me to occupy the Event lab and to look through the eVolution 3E ventilator. So, as we see, I've already plugged in the ventilator. It doesn't necessarily have to be plugged in. It can run off of an internal battery, and it gets about 5 hours of battery. Now, one of the clues here as to the type of ventilator we're talking about is that it only has one manifold for gas. Generally speaking, you'll see two manifolds, one for oxygen and one for air, in an ICU ventilator. But some ICU ventilators have emerged that use turbines or blowers, and in those cases, they only require oxygen. So I'm going to attach our oxygen hose. We'll run the ventilator on 21%, but just to show you how it works, I'm going to go ahead and attach the oxygen hose. You can see the green color code, and I'm going to reach up above and plug it in just a minute. Here you have the on-off switch, and there's a protector. And this ventilator has an Ethernet out. Kind of interesting. We'll talk about the Clinanet a little bit later on another podcast. Right now I just want to show you how to get the vent started. So I'm going to rotate the ventilator around, the star of the show, and we'll get some close-up views. Reaching behind here, I'll flip the switch, but before I do, I just want to point out, here we have an exhaled manifold. You would attach your exhaled circuit. You can put a filter there, generally recommended, especially in COVID days. This block is heated. And you have your inspiratory manifold. I'll be attaching the inspiratory line. Generally speaking, circuits are blue on the inspiratory side and white on the expiratory side. But that's not a standard, it's just a general statement. Event happens to have a dual adult TTL, and although they also have other more sophisticated breathing test lungs, I'm going to use the TTL in this demonstration. It allows me to pick a resistance and also change the compliance. So let's hook it right here. Right now I'm just using a number 5 resistance. That's pretty common. And the compliance is set at 30. 30 is what we've been seeing. Generally, a spontaneously breathing person, healthy person's compliance is around 100. As we intubate them, we impose restriction, and that restriction usually manifests in a way that our compliance drops. And that compliance then sits anywhere between 50, 60, and again, this is milliliters per centimeter of water. This is how much airflow, how much volume can we inflate the lung with, and what force is required. So I've attached the ventilator. Now I'm going to the ventilator circuit. Now I'm going to turn the ventilator on, and we'll see a power on self-test. You can see the front illuminate. On the front dial, we have, while we're going through our power on self-test, I'll go ahead and show you a little bit about the front of the ventilator. This is a rotary encoder. As you rotate it, you're able to change the values of your ventilator settings. You're also able to push on it to accept. This ventilator, like many of the high-end ventilators, uses a touch something on the touch screen. This is a touch screen. Turn the rotary encoder and accept. Another thing found in ICU-based ventilators is the ability to quickly increase the FiO2. You may have noticed the light illuminated on the top, and this is where you would see alarms, cautions, etc. It's placed on the top of the ventilator so it makes it visible throughout the intensive care unit. Here we have the ability to increase oxygen by pressing this. And this ventilator also allows you to, in the neonatal area, or even in the case of COPD, where oxygen has a high level of toxicity, you can set the level of oxygen increase, the step increase in oxygen. Here you have a manual inflation button, so every time you push this, it will deliver a breath. This is very useful in hyperoxygenation. These two buttons are located here at the left of the device. Increase the oxygen and manually ventilate the patient. It's a common procedure in suctioning or removing airway secretions. On the other side, you'll find a button that looks like the power on and off, and you'll have your ever-popular alarm silence. So the ventilator has went through its power on self-test, and now we're ready to get started. On the left, the ventilator allows you to choose between adult, pediatric, and infant patients. It also allows you, if you were ventilating a patient, took the patient off the ventilator, went to the operating room or to CAT scan, to return and hit current patient. There's also some other methods that you can use to quickly resume ventilation. The ventilator asks for you to choose an ideal body weight, and of course a tidal volume, if you're in volume-based ventilation, is set according to that ideal body weight, which also correlates to a height. Now we know that the height of the patient is more indicative of the chest cage size and therefore more indicative of the tidal volume. Once you pick your level, notice I did touch, turn, accept, then you're over here where you want to look at the calibration area. Now for this demonstration, I'm not going to go through the calibrations, but they're simple. You can calibrate the circuit. You can calibrate the circuit and determine the compliance and resistance of the system, of the breathing system. You can calibrate the expiratory flow transducer, and you can calibrate the oxygen sensor. This ventilator, like all ICU ventilators, comes with a built-in oxygen sensor. This one is a galvanic sensor. Once you've chosen what you need, then you're also given an ability to choose the type of humidification you're using. You can choose between a heated humidifier, an HME, or when you're playing around the lab, you can choose none or testing. Once all of this is done, you hit accept. You'll see a blue light, and then you're taken to the area where you will choose the mode of ventilation. This ventilator has a rich set of modes of ventilation, and these modes of ventilation are organized according to the American Thoracic Society's taxonomy. We know that patients breathe spontaneously, that when we want to, we control their ventilation, and then there's the mix between that called SIMV. We also know that all ventilators either target internally a pressure level or a volume level. So the breath types which fall under the mode allow you to choose pressure-based breaths, where you're targeting a peak pressure, depending on the derivative of the mode, how long that pressure is maintained. You're also allowed to choose a tidal volume, if volume ventilation is what you're used to or comfortable with. In addition to these modes, the mode of CMV, the mode of SIMV, and the spontaneous mode, you're able to use a mode called auto control. Auto control is a very, very important mode used often in weaning, but also in general care or general ventilation of the patient. By using auto control or auto modes, most ventilators allow a rapid response to changes in patient breathing behavior, and that allows for the ventilator to respond rather than waiting for a caregiver to recognize a change in the breathing. We are familiar with modes or with subsets of modes like apnea backup, but auto control is a different method that we'll cover on another video. In addition to this mode, you actually have the ability to use this ICU ventilator to deliver high flow oxygen. Now we know in the COVID time frame, in the COVID-19 time frame, that high flow oxygen has been talked about a lot. An ICU ventilator, the quality of ventilator that I would want my loved ones placed on, if God forbid they need to be, must have or should have the flexibility to treat the patient throughout the continuum of care. So let's talk a little bit more about these various modes on another podcast. Right now, I'm just going to start a pretty simple mode, and then we'll put an end to this particular podcast, and we'll pick up on modes of ventilation. We can also talk about specific controls. So what I'm going to do is I'm going to choose SIMV because that will give me the most controls, and that will allow me to talk about general ventilator care. So I've chosen SIMV. I'm going to choose pressure support, or I'm sorry, PSIMV. That means pressure targeted SIMV. Notice that as I change the types of SIMV, whether it's volume or pressure, or PRVC, yet another very important mode we'll cover, the parameters along the bottom, the pertinent parameters, are presented. Again, take a look along the bottom section. In this ventilator, very similar to other ICU quality ventilators, you'll find patient monitoring above, digital monitoring. You'll find the pertinent parameters along the base. Pertinent parameters are parameters that you need to change often, or that are very specific to the mode type of ventilation, or to the breath type and mode type of ventilation. And then you'll have waveforms across the screen. We'll talk about waveforms later. I was involved in the very first edition of waveforms, first commercialization of waveforms on the 7200. And this ventilator does a great job of giving you the flexibility to look at waveforms. So again, I'm choosing PCMV. The first knob I'm touching is oxygen. I'm going to turn it down to 21, just to make things easy. No need to waste oxygen. I'm going to choose a rate. Now, when I want to choose a rate, you might notice that you see IE ratio, the time of inspiration, and the time of exhalation. As I rotate my choice of rate, I'm presented with the impact that will have on these variables: IE ratio, time of inspiration, and time of exhalation. This is important for physicians and therapists as they set a ventilator to look at the impact prior to enacting it. Okay, I chose it. I'm going to go with a rate of 10. I did my touch, my turn, and my accept. The next parameter, besides rate, is the time of inspiration, the PEEP level, the positive end expiratory pressure, we'll talk more about that, and my level of pressure control. Additionally, this ventilator allows you to set up other parameters such as flow triggering. If you want to do pressure triggering, you'd simply touch, turn, accept, and this changes to pressure triggering. In other words, I now see a value of centimeters of water pressure. I have a history of flow triggering, so I won't bore you on this video. I'll pontificate like all of us old men do on another video. So I'm touching it, turning it to flow, and accepting it. Now I have the parameters I'm interested in. Let's get started. You can see the test lung is being ventilated. Ventilation started immediately. Waveforms are available. I have a PV loop, a pressure volume loop, as well as my waveforms over time. Now sometimes I want to see these waveforms in a different way. I want to see them larger. I may pick my two favorite waveforms. This ventilator allows you to easily choose between waveforms. Here's a single waveform, pressure over time, but I'm a fan of pressure over time and flow over time. So here we are. Again, digital parameters, what's going on with the patient's breathing, what's the patient's settings, and should any alarms occur, I'm able to get started immediately by looking at the alarm screen. If I want to, I can choose an auto set. An auto set will allow me to set parameters below and above the current running variables of the patient, the current breathing parameters, the current breathing of the patient. Auto set automatically sets it, and I can get going to do my other important work. If I did desire, or if I did have a case where the ventilator was alarming, one of the things I love about this ventilator, let's go back to the home page, I'm going to turn off my PEEP. I'm going to go 0 on my PEEP. And as soon as we get a breath and it starts to hit the baseline, my PEEP alarm is going to come up. So right now my PEEP has hit 1. Next breath, we should start to get an alarm. There we go. It's telling me on the screen there's low PEEP. Now I could go to the alarm setting, or I could simply touch the alarm indicator itself, see that PEEP is low. If it's something I intended to do, then I can easily adjust my low PEEP. I touched, I adjusted, I turned, and I accepted. Now, after a few breaths, we'll notice the alarm is cleared. But if an alarm occurred while you were away from the bedside, you're still presented, when you come back, a latched alarm. Again, these are the critical features that you'll find in an intensive care ventilator. It's telling me that there was a low PEEP occurrence and that it was adjusted. I know that, so I can clear it by simply touching. And away it goes. So these are the features I love in a ICU level ventilator. Another thing that I like about this ventilator is I can choose which digital parameters I monitor. If I want let's say I want the tidal volume inspired, or Let's say the time of inspiration up here. I hit peep, it turns yellow. I touch the parameter I desire, and it now replaces that. Now, of course, all the parameters are continuously monitored, but those that I deem important, generally related to the mode of ventilation or the patient condition, can be placed up above in this digital strip. Right now, I've chosen 5 parameters to monitor, but you can choose 8. Okay, so this is the eVolution 3T. Truly an ICU ventilator. For now, this is Steve Tennell, thanking you for tuning in, and please join us on our next ventilator